Welcome to week 7. So we are in our final week of actual learning here. I want to first give you some information regarding next week. Okay. So next week, Monday, May 18th, and Tuesday, May 19th. Okay. What I want to tell you here is that these days are required. Okay, meaning you are expected to be online during your block. Okay, I will send you invites for those as we get going here, but you are required to be at those classes. Okay, Monday, May 18th and Tuesday, May 19th during your block. Required. All right, so here we are at week 7, day 1. We are still solving rational equations. After you get this question written down, the first thing I want you to do is I want you to factor that denominator of the first one. All right, there is what it should be when you factor that denominator. Okay, so all I've done is factor that denominator so far. Just like the last week prior to this, we are going to look and see, well, what does one have that the other one does not have? And especially on this side right here, where they have 2 of them that are different denominators, okay? If I look at those 2 alone, to be able to subtract those, we know that they have to have a common denominator. So I can multiply this first fraction by what it does not have, which is that x minus 3. And I can multiply this second one by what it does not have, which is the x plus 5. Go ahead and pause and do that. All right, that is what you should get for both of those once you have them simplified in like terms combined. Okay, now some important thing on that right-hand side. So if I ignore the left-hand side for just a minute, okay, and I look at just that right-hand side, I can combine those 2 together. One big thing that you need to remember here is that this minus is subtracting this entire numerator. All right, go ahead and subtract that. And we'll bring our left side back in here. Okay, now that those are subtracted, this is right back into last week. We have like denominators on the left and the right, and so if my denominators are the same, then that means that my numerators must equal. Okay, so now I'm in this situation where I have a 2x squared plus, or minus 13x plus 13. Equals the x plus 1. Because of this x squared, that lets you know, hey, you're probably going to factor. So let's go ahead and get this set equal to 0. All right, now that it is equal to 0, we are going to need to factor this. You can make it a lot easier on yourself right here. You could say, hey, 2, 14, and 12 all have a 2 in common. So you can actually go ahead and divide both sides by 2 to make your numbers smaller here. So that I have x squared minus 12x. How about minus 7x and not minus 12x? Plus 6. I wrote 12 again. Guys, come on now. Minus 7x. There we go. Plus 6 equals 0. Hey, I want you to factor that on that left-hand side and get your values of x. All right, once you solve it, you should get those 2 values. X is 6. And x is 1. Now, something I forgot to do up at the beginning that I will be better on my next problems here, but I can go back and look at it now, is x can't be some value. So if I look back here, once I had everything factored, so looking up here, where I had everything factored, okay, what can x not be? Well, I have an x plus 5, so x cannot equal negative 5. And I have an x minus 3, so x cannot equal 3. As long as I don't get those 2 answers, my answer should be perfectly fine to be my answer. So this question actually has 2 answers sometimes. They both will work. So it has the answers of 6 and 1. Sometimes 1 might work and sometimes neither of them might work. All right, so here's that next question. I want you to write it down and then factor the one denominator that can factor. All right, that middle rational expression, 5 over x squared minus 9, factors using a difference of squares, okay? I'm going to do this question a little bit differently than the last one, in that I'm going to look at all three fractions to figure out what they need to be the same. So for instance, this middle one has an x plus 3 and an x minus 3. So that's probably going to be the one that I want to try to match here. So my first fraction has only an x plus 3. So what does that tell me? Well, it tells me that this first fraction needs an x minus 3 so that it can be the same. And likewise, on the other side of my equal sign, I have 2 over x minus 3. And if I want it to be the same denominator, I know that this one needs to have the x plus 3. And if I look quickly, it means all of them now will be the same. Go ahead and multiply those fractions by those values. All right, now since they are all the same, I can actually use that because they're all the same, I can just take the numerator straight across and keep the signs. Now, I wrote this one different on purpose to show you that x minus 3 times x plus 3 is the exact same thing as x plus 3, x minus 3, okay? Because all three denominators are set equal to one another, or not equal, but are the same, there we go, I can set just the numerators equal, meaning I can take the x minus 3 plus the numerator 5 and set it equal to the 2x plus 6. Go ahead and solve that equation. Alright, so I end up with that x should equal negative 4. Now I did it again, I forgot to say what x cannot be. So if I come up here to the beginning where I had everything all factored out right here, okay, and I say, hey, what can x not be? Well, x cannot equal negative 3. X cannot equal positive 3. And as you can see here, I got negative 4. So that is my solution here because the values that x cannot be were 3 and negative 3. All right. Next question. Go ahead and write it down and again factor what can be factored. And go ahead and write what x cannot be while we're at it. All right, there is what x cannot be after I have that denominator factored. Okay, what I want you to do next is I want you to pause it and I want you to multiply the rationals that need multiplied so that they all will have a common denominator. All right, there is what you should have multiplied each fraction by so that they have a common denominator on each one. So because all three have a common denominator, you can go ahead and set the numerators equal to one another and go ahead and solve. As you can see here, I did not get what one of my x's cannot be here, so x equals negative 6 is my solution. Go ahead and write down the question and factor the denominator that can be factored. Alright, here's what you should have when you factor the denominator of that second fraction on the right side of the equal sign. Okay, now, you may have noticed as you wrote down the question that two of these already had a common denominator. So because they already have a common denominator, we can actually combine them together. Now, because they're on opposite sides of the equal sign, we can't just go, boom, you're together. We have to make sure that we move the appropriate one over to the other one. Okay, meaning I have this 1 over x plus 2 that's on the other side. Well, I can subtract a 1 over x plus 2 on both sides. Subtract a 1 over x plus 2. Well, what does that mean? Well, if I have an x plus 6 and a negative 1 that are with a common denominator, this means on the left side I have an x plus 5 over x plus 2 equals, now I want you to be super careful here because there is a negative, equals negative 27 over x minus 7, x plus 2. Now that you have this, I want you to get a common denominator on that left side so you can set the numerators equal. to get a common denominator, we will have to multiply by x minus 7 on the left. Okay, right here, I'm also going to say what x cannot be real quick because the factors are going to be the same. X cannot equal negative 2 and x cannot equal a positive 7 in the end here. Go ahead and multiply that left fraction together. There is what you should have when you multiply that left-hand fraction together and simplify. So now we are ready to set those numerators equal. X squared minus 2x minus 35 equals negative 27. Again, I have that x squared there, so that means we're probably going to have to factor. So go ahead and get this equal to 0 and factor and find your values of x. Alright, there is the values of x. I got x equals negative 2 and x equals 4. But we know from up here where x cannot be, that x cannot actually equal negative 2. So only one of those two answers works. Alright, I have one last question here for you. So what I'm going to do is I'm not actually going to talk much. I am going to pause and play throughout the question, and you can do it step by step and see if you are correct. Okay, so here's the question. I would suggest maybe you start with factoring, but the denominator of the one that can factor. But that's about all I'm going to suggest to you. I'm going to pause and play step by step. Alright, so there you have it. X equals 9 for that question, and that is it. Hey, another reminder here that May 18th and May 19th, okay, these 2 days are required, okay, so required that you are in class. Okay, so required on these days. Very important. Put them in your calendar now. Okay, have a great week.